So they're very important concepts. And you can say, yeah, I can put them side by side and FOIL. True. But it's a good idea to move away from that, because you're now taking calculus. So I guess I think it's a good idea. So remember, this is a binomial squared, right? So today is the 15th. Can you see everyone? Yes? Okay, perfect. Yes? Does anyone have difficulties, or is everyone okay?
Yeah, it's a little.
Yeah, it's a little bright.
Yeah, slightly bright, but other than that.
So if I do this, then you can see.
Yeah, that's a little better.
Yeah.
Really?
Yep.
Okay, well, okay, I have a light on this side and one on this side, so actually two on the left. Anyway, perfect. So we have a plus b everything squared, which, anyone remembers what does this equal to? So this is a binomial squared. Anyone remembers? Well, let's FOIL it then for the first time, and the last, I hope. A times A is A squared, A times B is AB, plus B times A, which is another AB, plus B times B, which is B squared. These will be combined like terms, so then the answer is A squared plus 2AB plus B squared. Is this okay with everyone? So a binomial squared is a trinomial. Binomial squared is a trinomial. So what will be the difference here? Well, if the binomial has a sum, the middle term is has a positive symbol or sign, but if it's minus, then that's the only change. So for example, how I would like us to use this, let's say we have this situation. I don't want us to FOIL anymore. Why? Because factoring will be a problem, and we're saving some time as well. So remember, this is the first term squared, the second term squared is here, and this middle term is 2AB. This is my A, and this is my B. So obviously I have to square the first term, and I write 4x squared. I have to square the last term, and I write positive 9y squared. And the middle term is this product, which is 6xy multiplied by 2. The product of A and B, 6xy, multiplied by 2, which is 12xy. And there is no need for all this. How do you feel about this? Anyone? Are we okay? So the same thing with the negative. If you don't say anything, I don't really know whether you're following or you need any help with this. Are we okay, everyone? Okay, then this is another very important special product, this one. And it's called the difference of squares. So the difference of squares is, let's FOIL it just the last time, I hope, A squared minus AB plus AB and minus B squared. In this case, that's why this is called the difference of squares. It just is a difference of squares. So the requirement is that these two are the same and these two are the same. The only difference is plus and minus. So if I have 2x plus 4y, let's say, and 2x minus 4y, This may not be the best color. Then all I have to do is just square the first term and subtract when I square the second term. And it's done. So that's all I wanted to say about that. So from here we remember that the difference of squares also factors into a plus b, a minus b. Also, we have to remember moving forward that a binomial square is a trinomial. Because I still have students who say that x squared minus 3y squared is x to the fourth minus 9y squared. Which, of course, would be terribly wrong, because a binomial squared has 3 terms, which means I square the first term, I square the last term, this is minus, I have to write minus, I multiply these two to get 3x squared y multiplied by 2, so minus 6x squared y. You don't have to wait for me to stop and ask you whether you have questions. Please speak up if you have any questions. Anyone? Okay, so now I would like to actually start the R chapter. Are we okay? Are we comfortable with this? Okay, perfect. So R is considered review. But I'm going to go over everything in R. So it's called functions, graphs, and models. Chapter R. Functions, graphs, and models. And let's start with R1, R.1. Graphs and equations. Again, you will tell me whether I should move on faster, that because you understand all this and you remember, or slower. Okay. I would like to look at problem 9 on page 10. And when you get to, you don't have to purchase the book, as I said, but I forgot to show you the Multimedia Library. Should I show you? Are you okay with finding the Multimedia Library in my lab math, or should I show you and share the screen? Anyone? Should I show where to find it? Okay, maybe we should do that. Okay, sorry about that. 1 second. I forgot to show you. Good. I'm sharing my screen right this moment. Okay. So here it is. Under Course Tools, main menu, right here, Multimedia Library. Again, I can't see because of all this equipment in front of me. So, Multimedia Library, let's say we check our functions, graphs, and models. Let's say we have to select all. Let's say we're looking at section R.1. You click on Find Now and scroll down. It will give you the Multimedia Library, the PowerPoint presentation. Here it is, the textbook, and all these videos showing you how to graph, or examples, introduction, business compound interest, etc., etc. You have all these videos here as well. So the textbook is right here if you already have access to the course. That's how you find it. The other thing that I just realized I forgot to show you is this: how to enter my lab through my lab and mastering. So you register after you log in Canvas, go to our course, and click on my lab and mastering. And it will take you step by step on how to register in my lab lab math. They just changed it. It was my math lab. Now it's my lab math. Whatever. Okay, and once you enter, it's another way of getting to the book and the assignments and everything else. Any questions on this? Okay, so back now. So problem 9 on page 10, it's asking us to graph the following equation, 6x plus 3y equals negative 9. First of all, can we establish what type of equation is it? And why? What type of equation is it? Because the variables have power 1 and there is no product of variables, this will not be linear. So this is a linear equation. The linear equation requires only 2 ordered pairs to graph. The easiest, I do not recommend you solve for y and find the slope, etc., etc. There is no need for that. Obviously, I realize that I can simplify the equation, dividing everything by 3, and we should do that. So 2 key words, not just words, but also concepts. In all math classes, I would like you to have in the back of your mind at all times, factor is one very important concept. It should be in the back of your mind at all times. And the other one, simplify. These 2 concepts should always be with you. Okay, so yes, I see that 6x plus 3y equals 9. All these terms are divisible by 3. And I will divide and I get 2x plus y equals 3. Now, whenever I graph a linear equation, or any function for that matter, I will always look for the x and y intercepts. Always look for the x and y intercepts. Always. If they exist. In certain situations they may not, but I will always look for the x and y intercepts. Okay, how do I determine the x-intercept? Well, it's a point somewhere here. I don't know where. Maybe here, maybe here, maybe here. What do I know about points on this line, which is the x-axis? They have something in common. What do they have in common, all of them?
All real numbers.
Say it again.
All real numbers.
True, but they all have in common something. Correct. Yes, from negative infinity to positive infinity. Great job. But they all have in common something. All of them.
Y is always 0.
Very good. Y is always 0. Which means that the equation of this line is y equals 0. If I want to determine the x-intercept, I must set y equal to 0 to find the x-intercept. Bless you. Okay, no problem. I make y equal to 0. It's gone. How much is x? How do I get x from here? I covered it because it's 0. Y equals 0. I covered it. So how much is x? Anyone?
1.5.
Yes, 3 over 2. Very good. So then x equals 3 over 2. So can anyone give us the ordered pair that we will graph? I should say plot, in order to graph the equation of the line. What is the ordered pair? Excellent. Very good. Awesome. So now I want to determine the y-intercept. It's a point somewhere here. What do they all have in common? All these
X is 0.
x is 0 indeed. The equation of this line is x equals 0. So if I want to determine the y-intercept, I have to set x equal to 0. Okay, no problem. I set x equal to 0. It's gone. How much is y? Yes, indeed. So then what is the second ordered pair that I need to plot in order to graph this equation? Excellent. Great job. So now we are ready to graph. So let's graph.
Excuse me, is 3 supposed to be negative?
When x is 0?
No, because when you first wrote it, 9 was negative.
Yes, of course. I'm not asleep. I'm not asleep. Thank you. Thank you. Thank you. Thank you. Thank you. My mistake.
So wouldn't the x be negative 3 over 2?
Yes. Thank you very much. I did not copy the negative 9. I went ahead. I talked too much. Told you. My mistake. My apologies. Sorry. Very good. So indeed, when y is 0, x will be negative 3/2. And when x is 0, y will be negative 3. Negative 3/2, 0, and 0, negative 3. Thank you very much. Sorry. Okay, we're ready to graph it now. Good. So 0 for x, negative 3 for y. Negative 3/2 for x, 0 for y. We connect and extend the line. This is the graph of either 2x plus y equals negative 3 or the original 6x plus 3y equals negative 9. Great job, thank you. Any questions on this? Let's refresh our memory on a different type of function, 14 on page 10, and that is y equals x squared minus 3. What type of function is this? What type of function is this? Obviously, it's not linear because it has power 2 on x. We call this quadratic. It's a quadratic equation. Okay, we have several ways in general of graphing, and here is one because I'm hoping that you remember how to graph this. Do we remember how to graph the simplest possible quadratic function, which is x squared? Well, I should create a little table and show you. Let's say negative infinity to infinity because that's the domain. Let's say negative 2, negative 1, 0, 1 to infinity. When I plug in 0, I get 0. When I plug in 1, I get 1, or in both situations, and 4 and 4. So this is the graph of x squared. It's a parabola with the vertex at the origin. Opening up, because the leading coefficient is 1. When the leading coefficient is positive, the parabola has a minimum. When the leading coefficient is negative, the parabola has a maximum. Okay, but the function we have is x squared minus 3. Well, this is one transformation that I hope you remember. It will pull the graph down 3 units. So it's a transformation on y values. So if I graph x squared, and then I graph x squared minus 3, the entire graph goes down 3 units. So an exact graph will ask us to determine the x-intercept. The y-intercept is very clear. It must be here. Because the graph started at this point, this is the x squared, and pulling it down will mean this. So this is y equals x squared minus 3. Of course, these intercepts have to be determined. At least that. How do I determine the x-intercepts of this function? In the same way we determine the x-intercepts for the previous function, for the linear equation, if you want, or linear function. So again, what is the equation of this line? What did we say was the equation of this line?
Y equals 0.
Y equals 0.